Hello everyone, today we are going to discuss the database lifecycle. Today is our third lecture. In our first lecture, we looked at the database approach. In our second lecture, we discussed the database environment. Today we are going to discuss the lifecycle of the database. We're going to see at what step do we start and where do we end. So these stages, there are 11, starting from planning, then we go to requirements elicitation, systems definition, deciding on which database management system to use. Then also we look at database design, implementation, testing, and maintenance. So this is what we are going to discuss today. Okay, so the objectives of this phase one, we're going to look at the main phases of the database application life cycle, and then also we shall discuss the main phases of the database design, which are essentially three: the conceptual, logical, and physical design. Okay. Also, we shall try to see how, one, in the process of database management system, how do you select a database management system, and then how do you evaluate it? So these are the 11 phases of the database lifecycle that we are going to discuss today. We have the database planning, we have the systems definition, we have the requirements collection and analysis, then we have the database design, then we have the database management selection, which is an optional phase. Then we have the application design, then we have prototyping, again, also that is an optional phase, implementation, data conversion and loading, testing, and then operational maintenance. Those are the 11 phases that we are going to discuss today. So this is the illustration that we're going to use. You have the database planning, systems definition, you have the requirements collection and analysis. Within this, you have the database design, which is in that box. So database design involves conceptual database design, logical database design, and physical database design. Then before the logical database design, we select the database. We need to select the database management system that we are going to use, but we're saying that that is an optional phase. So after the database design, we go to application, prototyping, we go to prototyping, and which we said is an optional phase. Prototyping is an optional phase, and then also we go to implementation. Okay, so depending on whether you're going to do prototyping, if you're going to prototype, then you take this angle and then you do your prototype and then you go back up. That becomes an iterative process, and we're going to see why prototyping is an iterative process. But if you do not wish to do prototyping, then we are going to go to implementation, the implementation phase. Now, if you look at if we go back to the requirements collection and analysis, there is a branch out to application design. So we're going to see what application design is involved. But we know one thing that we need to be certain about is we have what you call the design of the interfaces, and then the design of the transactions that are going to be part of the database management, of the database. So you have this application design, but with this application design, still it goes through conceptual, logical, and physical design. Then after implementation, when you're done with your application design, it converges down here. And then depending on whether you're going to do prototyping or you're going to proceed with the implementation, then you go to data conversion, then you go to testing, and then you finalize with maintenance of the database. So basically those are the stages that we'll have in our database life cycle, and we're going to discuss each and every particular phase in detail. So we have phase one. Phase one is the database planning. Now, what is involved in the database planning? Planning, just like any other activity, okay? All of us do carry out, all of us plan. When you wake up in the morning, you plan on how you're going to spend your entire day. When you are going for a meeting, you plan on what you're going to talk about, how you're going to deliver, etc. So the same thing applies with planning of the database. So we're saying that management activities that allow stages of the database application lifecycle to be realized as efficiently and effectively as possible. So this plan has got to be integrated within the overall information system strategy of the organization, because planning is paramount for the acceptability of the system. So what do? We need to know what the database application is going to do. So in the process of planning, what do you need to know? We need to know what the application is going to do, what area is it going to be applied in. Instance, are you going to design a database for a particular department, or you're designing an enterprise application? So you need to plan for that. And then also you need to know who will be using the application. So in the process of planning, you need to identify the mission statement. Okay, the mission statement is that overarching objective of your database. So we are saying that you have a mission statement for the database project, defines the major aims of your database application. What is that overarching objective for you to have this database in your organization? So those driving the database project normally define the mission statement. It could be a sponsor, it could be the owner, it could be the CEO. So whoever is behind the database is in charge of having the mission for that particular database. So the mission statement helps in clarifying the purpose of the database project, and it kind of gives us a clear path, okay, on how we shall efficiently and effectively create the database that we need. So after defining your mission statement, you have got to define your mission objectives. The objectives are now what you break down the global statement into tiny achievable statements that could be in form of tasks. So each and every particular objective should be defined such that you can achieve a particular task, or it helps us in identifying the particular tasks that the database is going to support. So it may be accompanied with other additional information that specifies the work to be done, the resources to be used, who is going to be part of this, the overall financial support, and who is going to be the financier of this particular database. So planning for the object. Now, if you look at this particular table, it has the mission objectives. Now, these are coming from the global objective, or the overarching objective. So you have the different stakeholders or the different users in your data that are going to use your database, and this could be the goals that they want the database to achieve. So for example, the director would say, we want a database to maintain data on the different branches. Then you have the director stroke a manager, they want to maintain data on staff. So these are the different users of the database, and these are the objectives that they want the database to achieve. So that is why it is imperative at the planning phase to identify or to come up with the mission objectives, such that you can be in position to achieve or to develop a database that is going to be useful to the people in the organization. Then in doing your database planning, okay, you should also include the development of standards, okay? So these standards, what are they going to do? Or what do you want? What are you envisaging? So you need to plan on how data will be collected. You need to plan on which format the data will be collected. You need to plan the necessary documentations that you shall need for our databases. For example, are we going to need ER models? Shall we need this conceptual designs? Are we going to in any way need, let's say, the user manuals, the source code, etc. So also development of standards may involve how the design will be achieved. So planning is a critical stage. It usually takes a lot of time. Why? Because this is when you need to ascertain the feasibility of your database. And this involves doing feasibility. It could be financial feasibility, market feasibility. You need to know your human resources in whether you have the required skill to implement the human resources. Then you need to do an HR audit to see who requires training at the end of when the database is installed in the database, who requires training, and so on and so forth. So usually it takes a long time, but at the end of the day, it kind of provides a basis for, let's say, staff training, a basis for us to fund the database, quality control, among other things. So after planning, we go to systems definition. Now, systems definition essentially looks at the boundary of the project. It looks at the scope of the project. So organizations usually have, let us look at Makerere University, okay? This is our Makerere University. Makerere University has different departments, okay? You have the Department of Finance, okay? You have the Department of, let me bring this closer such that you can see. You have the Department of Finance. Oh my God. This is a permanent marker. Let me get a whiteboard marker. So you have the Department of Finance, you have the Department of Marketing, okay? You have HR, you have Academic Registrar, etc. So these are the departments that we have at Makerere University. Now, we're saying that when you are doing a systems definition, you need to describe the scope. You need to describe the boundaries of the system. So you need to ask yourself, okay, what user views am I going to have for my database? And the user views are going to be judged, or they are going to be generated from the different either users or the different departments that you have in your organization, okay? So that is how you are going to generate your user views. So the user views looks at, one, who are the users of your database, who are going to be the users of the database, and these users, or what particular department is going to use the database. So that is the systems definition. You're trying to identify and scope out who is going to use the database. So it involves describing or identifying how the database will interface with other parts of the organization's information system. So again, we're saying that if if we already have an information system in the organization, at this point in time, at the stage of systems definition, we are trying to see, or we shall be in position to see, how the database that we are planning to design, how does it fit with the existing information system. So you will be having this existing information system already in your organization, but then you're having this database that could probably be looking at only the finance department, okay? You only want to design a database for the finance department. So if your scope is only the finance department, then at this stage also you need to see how are you going to integrate the user view of the finance department to the existing information systems in your organization. So user views define what is required of the database application. So in other words, you are in position to know that this is the user view that I am going to have. We shall have a user view for the finance department. We shall have the user view for the marketing department. We shall have a user view for the HR department. That is now at enterprise application area. Or you can have a user view in terms of a job role. You could be designing the database for only managers. You could be designing a database for only supervisors, team members, etc. So that is the user views and the definition of it. So now what you have there, you have a systems definition of a given company X. So company X has the marketing department, it has the payroll, it has property sales, human resource, etc. So if you look at that particular department X, which is a fictitious department, okay, you can decide that you are going to create a database for, let's say, properties, property rentals, or property advertising, or customer service, or the HR human resource department. So whatever it is. So what you need to know at this stage is systems definition is just looking at the boundary and the scope of your system. So database applications may have one or more user views. That is very true. A database application can have one user view, but also it could have different user views. And for each and every particular user view, you need to understand, or you need to illustrate what data it will have and the transactions that are going to be in that particular user view. Along the way towards the end of this lecture, we are going to see that we're at the point of application design. The point of application design, you do the design of the interfaces and then also do the design of the transactions. But at this systems definition stage, you need to get to know the data that you're going to have for each particular user view. For example, the user view marketing, the user view human resource, what data do you need? And then also need to know the transactions that are going to be involved in that particular user view. So, in essence, identifying user views helps us to ensure that there is no major user of the database that has been excluded, knowingly or unknowingly. So by trying to break down your database, by trying to break down the user views, it helps us, because in identifying the user views, or by having what we call a systems definition, then we shall be certain that there is no user in the database that is going to be left out. So that is why it is important for us to have the user views in our database. Okay, so also the other important thing that user views do, the user views help us in the development of a complex database. Think of a database like a database for a telecommunication company, a database of a university. Now, if you have a database of a university, I bet that this database has huge user views, or it has very many user views. It has very many transactions. It has very many users. So with with breaking down the user views or having what we call a systems definition, it helps us to break down something that is big to something that is manageable, to smaller pieces that can be implementable, that can be designed, that can be that we can easily design. That is why the user views are important. So this is a representation of a database application with multiple user views. So what you see there, for example, this is a database application. So that is a database application that has, when you see user view one could be either a job role or it could be a department within an organization. So you have user view 1, you have user view 2, and that intersection shows that there is a particular component of these user views that is common for them, or there is a particular functionality in the database that is common. For example, you can find that 2 user views are both using the payroll system. Take an example of the accounts department. The accounts department uses a payroll system because they have to pay out people. But also the human resource department uses the payroll system because they need to know the status of their employees, who is going on leave, who has just come back from leave, who is getting maternity leave, who is resigning, who have we just recruited. So you find that there is some common features with of the payroll or the entire payroll between the human resource department and the accounts department. So those are the user views. So when you have these user views created, you will know which user view depends on the other, which user view shares data with the other, and so on and so forth. So that is why we have these user views. Then we go to stage 3. Stage 3 is, requirements collection and analysis, okay? And we're saying that this is the process of collecting and analyzing information about a part of the organization that needs the database. So, for example, you have the human resource department, okay? Now, this human resource department is in charge of recruiting, training, selecting, hiring, inducting, etc. All these are some of the activities or tasks that you're going to find in the human resource department. So it means that when we are designing the database, everything should be inclined to the activities of the human resource department. So at requirements collection and analysis, what do we need? We go and we collect data about that part of the organization that needs the database. And using this information, we shall be in position to identify users' requirements for the system that we intend to build. So whatever the user tells you, when the user tells you that we need a system that is going to do A, B, C, D, what they need the system to do for them is actually what is referred to as user requirements. So the information is gathered for each major user view, and this includes a description of the data used or generated, the details of how the data is to be used or generated, and any additional requirements for the new database application. So information is analyzed to identify the requirements to be included in the database application. So all the information that we get from the different users, that's why we call it requirements analysis and design. We sit down as an analyst, try to analyze this data and see whether you can be in position to actually get requirements out of it. It's these requirements that we use to design models that are going to later be translated into a system. So requirements collection, so gathered information may be poorly structured or it might be in form of informal requests, which in most cases users do. A user will tell you, we want a good system, we want a system that can be in position to add, that can generate reports. So most of the information that we get from the users is unstructured, it's unclear, it's ambiguous. So what do we do as analysts? What do we do as designers? We have to get this information and we make meaning out of it. So we're saying that this data must be converted into structured statements of requirements using different requirement specifications techniques, like you can have data flow diagrams, you can have activity diagrams, you can have sequencing diagrams, you can have so many diagrams that you can actually come up with just from the statements, unstructured statements that the users offered you. We use different modeling languages like unified modeling language to help us to actually draw these different diagrams. So the information is analyzed to obtain the requirements, which are stored in a document. This document is referred to as a requirements specifications document. So once all this information that we've gotten from the users, it has been now structured, is now understandable by the designer or by the implementer of the system, we get all that information and we store it in a document that we refer to as a requirements specifications document. Now, another important activity is deciding how to manage the database with multiple user views. So at the time of collecting requirements, we need to ask ourselves, how do we intend to manage the application that has multiple user views? Here, that is where we're going to discuss the three approaches: the centralized approach, the view integration approach, and you can have a combination of both approaches, okay? So now we have what we call a centralized approach. Okay. So we have a centralized approach. Now, this centralized approach, we are saying that the requirements of each user views are managed into a single set of requirements. So let us assume that you have user, let's say the finance department, okay? And then you have the human resource department, and then you have the marketing department. You have the marketing department. So with the centralized approach, this is what happens. For each and every particular user view, remember, these ones are user views. So for each and every particular user view, you create what we call a global data model. Now, what you have here as a global data model, in the data model, what do we have? We have documents, okay? We have diagrams or designs. We have designs. Within each data model, you have designs, okay? Excuse me. Excuse me. You have documents, you have designs, etc. Okay? So you'll find that in the centralized approach, each user view has their own global data model. Okay? So usually we do this centralized approach when you have a very simple database that does not have many users, and where you don't have user views overlapping each other. you can take on this approach. But then when you look at the view integration, so you have this global data model and then that feed into the end. So this is what we are looking at. You have these different user views, okay? Each particular user view has its requirements, user requirements. These user requirements, okay, are collected into one requirements document that we could maybe let's call it, let's say, a requirement specifications document. Okay, all the requirements of the different user views, they are collected in here, and then after that you have one global data model. Okay, so this global data model, I said that the data model has the documents. These documents could be in form of the systems, the requirement specifications document. It could have the designs in terms of ER models. It has the metadata and so on and so forth. So this global data model, and then you have your database. So this is the centralized. Now, the view integration, remember this is the global data model, the one that you see after all requirements have been integrated together. Now you have in the view integration, each user view or each user requirement has its own local data model. Okay, so this is a local data model. This is another local data model. This one is also another local data model for the finance department, for the human resource department, and for the marketing department. So you have a finance department, it has its own requirements, and from its own requirements, it has its local data model. That is, I'm trying to explain the view integration, okay? Then you have the human resource department, has its own user requirements and its own local data model. You have a marketing department, it has its own user requirements plus a local data model. Now, after having a local data model for each user view, then you combine them into a global data model. So now you have a global data model. In this kind of arrangement, it is used where you have a very complex system or a very big database that has many users, many transactions, and the user views are overlapping. That is when you use a view integration approach, okay? So each and every particular user view, what you need to know is each single user view has its own local data model. So these local data models are merged together to get what we call a global data model. So in essence, that is how a view integration approach would look like. Then you can decide to use a hybrid, to use both. You can use both a view integration and also a centralized approach if you choose, if it deems fit. Then you have a database design as our phase 4. It's a process of creating a design for a database that will support enterprise operations and objectives. What are the major aims of a database design? It represents data and relationship between the data required by all the major applications and user groups. So when we are talking of a database design, again, think of a design like a house plan, okay? I always want to use the analogy of the example of a house plan. So that is also the database plan. You have a design, okay? So the design will look like, look like this. This is just an example. So you can have a student, then you also have a lecturer. These are relations. And then you also have, let's say, a program, okay? A program entity. So the student is taught by a lecturer. A student is attached to a given program, okay? This is an example of a design, simple. I'm just trying to give an illustration. This is an example of a design, and this design one, you get to know the particular user views in your system, but most importantly, you also get to know the relationship between the different user views in your database. Then you have we are saying that the other aim of the database design is to provide data models that supports any transaction required for the database. For each and every particular user view, one user view can have one transaction, the other user view can have more than one transaction. Now, what is a transaction? A transaction is an action or series of actions that are subjected to your database, but these actions may, one, lead to the deletion of the deletion of the information in the database, or they may actually involve the update of data in the database. So a transaction is meant to change the data that is in your database, either by deleting or updating data in the database. So each and every, in the university database, for example, we have a course. You have what we call a course entity. Now, this course entity will record the coursework of a student for the entire semester. You do coursework 1, coursework 2, coursework 3 for the entire semester. And for each coursework that we do, we keep on adding marks. So each mark that you add to the coursework in the database is referred to, and your marks change. Those are called transactions. So at the end of the coursework, we put in an exam mark. The exam mark will make some computations are going to be made, and those computations are referred to as transactions. And then you shall compute your GPA and then compute your CGPA. The GPA and CGPA, because they are calculations, those are also transactions. So the database design provides data models that supports any transaction to your data. Then specifying a minimal design that is appropriately structured to achieve the stated performance of your database. It is imperative for us to have a database design because we are in position to understand, we are in position to get to know the appropriate structures, the appropriate structured format for the data that we are going to have in our database. So when you're talking about the database design, okay, what are we? So those are the different approaches of the database design. You have a top-down, bottom-up, inside-out, and a mixed kind of approach. So the most commonly used approach of the database design is a top-down. It starts from, it's like how you draw a hierarchy, okay? So top-down starts from identifying high-level entities, okay? You identify high-level entities, then you establish the relationship between these entities, okay? This is what we call the top-down. You start from high-level entities and then you go and then high-level entities and their relationships. Bottom up starts from the attributes within a given entity, and then it's cumulatively builds on the identified attributes. So let us explain this in detail. So the top down, like my demonstration, it starts from the high level entities and relationships. This is what I have shown, okay? So after which you go on incrementally adding a low level entities. That is a top down. So for example, we have what you call an entity relationship model. The entity relationship models that we are going to design starting from, I think, our lecture 5, okay, are referred to, that approach that we use to generate ER models is referred to as a top-down approach, okay? This one that I have just drawn, okay? So for example, for a university database, the top-down approach would be you have a student entity, you have the program entity, then you have a lecturer entity, and then you have a course entity. So this is the top-down approach. You start off by having the high-level entities. So, and then you create relationships for these entities. A student is attached to a program. A student enrolls for a course, like the courses that you're doing internet programming, data and information management, communication skills. So you enroll for a course. A lecturer teaches a course, okay? The lecturer also teaches the students, okay? So what you have here is an ER model. And what we have just done here is a top-down approach to database design. So we go to bottom up. What you need to know is when you're designing databases, you have what we call an entity. An entity is anything that you can hold data about. The entity can be an object, it can be a person, it's anything that you can hold data about, okay? So for each database that you're going to define, this marker that I am using is an entity. Okay, why? Because you can store information about a marker. You can store the color of the marker, the batch number of the marker, the serial number of the marker, the the manufacturer of the marker. So this one is an entity. If you go to a university database, student is an entity. Why? Because you can hold data about a student. You have the student's name, the student's address, the student's date of birth, the student's contact. So anything that you can hold data about is referred to as an entity. So this is what we have just done. Now, when we go to a bottom up, and usually this, okay, I will discuss it. But a bottom up begins at a fundamental level of attributes, and then you try to establish the properties of the entities and the relationship. This one will usually use it in normalization. Normalization is a bottom-up approach. Normalization and mapping, more of the logical design, okay? That is where we use the bottom-up. Now, demonstratively, you have, let's say, you have an entity called student, okay? You have that entity called student. Now, this entity called student has a registration number. all of you who are here, you have registration numbers. So registration number is a primary key. Then a student has a first name, a student has a last name, okay? And then a student has a date of birth. Now, with a bottom-up approach, okay, what happens? A bottom-up approach, instead of creating a data model like what we created, the ER model, it will start by one. They'll say, let us have a relation called students, okay? And then with this student, what are the attributes? You have an attribute called a registration number, you have an attribute called first name, you have an attribute called last name, and then you have another attribute called date of birth. Now, within these attributes, you start asking yourself, what is the relationship between the attributes? So what you're doing, finding out the relationship between the attributes of a given entity is what refer to as functional dependency. Okay, so now you say, okay, the first name and the first name, the registration number, no, that's wrong. The registration number determines the first name. That is a relationship. Then the registration number also determines someone's last name. The registration number also can define someone's date of birth. So you start by identifying the attributes within a given entity and then the relationships that are involved within those different attributes. Now, that is what we call a bottom up. So we're saying that the association between the attributes is analyzed. Attributes are closely related. They are grouped into a given relation. And then also others that have a relationship with the other, they are also grouped in another relationship. So this kind of approach, we usually use it in normalization. So when we get to normalization, we shall see how this works out. But this kind of approach is usually more efficient to a database that is very small or a simple database. Otherwise, if you're going to have a complex database, then having this kind of approach to database design is not advisable. Then you have an inside-out approach. Inside-out approach. Now, this inside-out approach, we're saying, it has some similarities with the bottom-up. That is the bottom-up where you are first identifying the attributes, but it differs by identifying major entities. So with the bottom-up approach, remember, for it, you start with the attributes and identifying the relationship between these different attributes. But the inside out, okay? Inside out, it starts with major attributes, okay? And then it spreads out to other entities. So this one will start with attributes and the association between the different attributes. This one will start with major entities and then it spreads out to other entities. But what makes it a bit similar to the bottom up is the fact that you have to establish relationships and attributes associated with the first one. In other words, we're saying that for the attribute, after identifying the major entity, okay, that is the major entities, then you go in identifying the relationships of the attributes of the different entities that you have identified. So that is how the similarity comes with the bottom-up approach. And then the mixed approach is where you decide to use any of the two. So now we go to still under database design, and then we go to data modeling. This is the process of building data models to represent a designer's understanding of the information requirements. What I have been building is what I have been drawing is what referred to as a data model. Okay, this. You have different entities, okay? These entities have relationships, okay? These entities have different attributes within it. This is what referred to as a data model. So what happens? You go and you gather requirements in your phase 2, and different users will tell you this, that, and so many other things that they will tell you. After that, then you're supposed to come back and draw data models from what the users have actually explained to you. So you create a data model, you generate entities, you generate attributes, you generate relationships, and then at the end, you have what you call a data model. So data modeling is a method used to define and analyze data requirements that are needed to support the business processes in a given organization. What are the major advantages of data modeling? One, they help us in understanding the semantics of the data. In other words, they help us to know what entities will we have in our database, what attributes are going to be attached to each and every particular entity. Then it will also, we shall be in position to get to know the relationships that are going to exist in the different different entities. So in answering these questions, it enables one to understand each user view's perspective of data. In other words, it helps us to understand what data we have for each particular user view, okay? The relationship between the data, and then also it helps us to know the nature of the data itself. So the other advantage of a database for creating a data model is it helps also in facilitating communication about the information requirements. Data models are a means by which a designer conveys his understanding of what the users wanted. So remember, when you go to the organization, you gather requirements, you write them down, you have an audio recorder, and then after, a designer is going to sit down, interpret what these people said in form of a data model. So it helps us in understanding what the users want in form of requirements. So it provides the two parties it provides the two parties that understanding of what, for example, the user wants and what the database designer understood. So we have three phases of the database design. You have the conceptual design, you have the logical and the physical design. The conceptual and the logical design corresponds to the first two levels of the ANSI Spark, and then the physical design corresponds to the last level of the ANSI Spark. So with the conceptual design, okay, we're saying that a conceptual data model is developed based on the data requirements for the application. Remember, when you go to the user, who wants the database. So whatever you collect, you sit down, you create something like this, which you call a conceptual model, and then try to, after creating something like this, you need to validate that model with the user's requirements to ascertain that whatever the user communicated has been reflected in the data in the conceptual design. So this conceptual design is the source of information for the logical design, okay? When you have this conceptual design, at the end, you will, the second phase of the database design is a logical design. So the logical designer uses this to create a logical design. We shall see how all this is done. So with the building a conceptual data model, you need to identify the entities, you need to identify the relationship types, you need to identify the associate attributes that are for each and every particular entity and the relationship types. You need to determine the attribute domain. For each and every particular attribute, they have domains. For example, registration number is 15 characters. First name is 10 characters. That is what referred to as attribute domain. Then you need to consider the use of enhanced modeling concepts, which is an option of his, but we shall see how it is done. Then you need to check redundancy to make sure that you don't have entities or data objects replicated. Then you need to validate your conceptual model against the transactions that the users communicated, and then you have to review the model with the user of the system. The person who told you to design the system, you have to go back and validate your conceptual model with their users to be certain before you actually go into the physical implementation. Otherwise, that is why most systems are rejected, because you did not validate your conceptual design against what the user originally wanted. Then we have a logical design. The logical design is usually the input of the logical design is the conceptual design. So the conceptual design gives us input into our logical design. And our logical design, these are usually relations, they are tables. That is the logical design. So the conceptual, we have an entity or entities, but at the logical level, we have tables. So you will have a table like this. Okay. For example, you have a table called student with a registration number, first name, last name. Okay. And then you have a first student whose registration number is this, is called Sarah XX. Then you have another student with a registration number. This is called Fred, etc. So this relation, okay. So before you have the data, okay, this is a relation, and this is at the logical design. The relation will give us, of course, the attributes, the data types, and many other things. But sometime before creating that, because sometimes you don't have the data itself, so you can just have what we call a schema. Okay, at the logical level, you have a schema. So this one here is referred to as a schema: a registration number, first name, last name. So a relational schema is a named relation that has that explicitly defines the attributes within a given relation. It is in a bar-like format. Now, this is what referred to as a relation, and this is what we usually have at the logical database design. What you have at the conceptual design is an entity that is going to be translated into a logical design, which is a relation or a table. So the model is also tested and validated against user requirements. The correctness of the data model, that is the relations that you're going to have, is tested using a concept called normalization. We're going to see how normalization, what normalization is and how it works. So the logical data model should also be examined to ensure that it supports all the transactions that are specified by the user. So the conceptual model is refined and mapped onto the logical data model to get what we call a relational model. The word relation is sometimes referred to as a table, and a table is a stream of rows and columns. So how do you build a logical data model? You derive relations for the logical data model. You validate the relations using normalization, validate relations against the user transactions. You try to check for integrity constraints, that is the referential integrity and the entity integrity rules. Then you review the logical data model with the user to make sure that everything has been captured, and then you match the logical data model into a global data model, which is an optional phase, and then you check for future growth. Then we go to the physical design. The physical database design is a description of how the logical database design will be implemented, how it will be implemented. That takes us back to as the 3 levels of ANSYS Spark. Remember, we said that the physical, the internal schema where you have the physical design describes how you will implement data in the database, okay? So it's the process of producing a description of the database. So the process of, description of the database and how it will be implemented on the secondary storage medium. I explained this in our previous lecture. So the main purpose of this phase is to create a set of relational tables and the constraints on these tables. For example, if there are any referential integrity constraints, if there are any entity integrity constraints. Then 2, identifying the specific storage structures and access methods. For example, are you going to have base relations? Are you going to have view relations? Are you looking at what type of file organization? Are you looking at what type of indexes are you going to use, and many others. Then also designing security protection for the system. What kind of security systems are you, security are you going to have on your database? So the database, the physical database design, the logical schema is transformed into a suite of specific database management system, and choices are made on the following. So in other words, the logical schema that you had has to be transformed into a specific database management system. But to do that, you need to choose the data types that you're going to use. Are you going to use integers, float, char, varchar, text, etc.? The data range constraints, that is in terms of domains. Then the requirement rules, okay? Whether or not a certain field is required. If it is not required, is it unique? Is it a primary key? Then also which values are going to be default values. In other words, which particular field is going to have default values or not default values. Cascading rules. We also need, at the physical design, you need to ascertain what particular fields are going to cascade on updates or on deletion. And then also you're going to tell us at the physical design, okay, whether you are going to have derived attributes computed or you're going to have them stored in the database design. So all this happens at the physical design. You need to know all these things during that phase. Then we have the database management system selection, that is the selection of the database management system. This one, it is an optional phase, but you need to know, are you going to use DB2? Are you going to use MySQL? Are you going to use SQL? Are you going to use Oracle? So at this stage, you need to identify which particular database management system you're going to have. And we usually do it prior the logical database design. The selection of the database management system is usually based on you want to know the performance of the database management system. You want to know the security features of the DBMS. You want to know the integrity constraints of the DBMS. But most importantly, you need to know the cost. You need to know the changeover requirements and costs related to changeover, any additional requirements, etc. So all those should be in position to guide you on the database management system that you should choose. So the processes that are entailed in the DBMS selection 1, you need to define the terms of reference of the study. For example, you need to know the DBMS that you want to use based on the criteria that I have mentioned in the previous slide. Then you shortlist the 2 or 3 products based on the criteria. Which do you think of the 2 products, of the 3 products, which of them fulfills the criteria mentioned? You evaluate these products. The evaluation of the products is based on, for example, the data definition, is based on recovery and backup. It could be also based on the structure of the database, expansion, etc. And then you recommend the best product that you want to use. So this has been explained in description of the criteria based on the requirements. Then you can be able to shortlist the products again based on those requirements. Those products that you're going to shortlist, you need to look at the enterprise budget, compatibility with the existing systems and the number of users. Then you evaluate these products. Evaluation of the product could be based on different features. For example, data definition, accessibility features, security, etc. And then after you recommend the best DBMS. Then we go to application design as our phase 6. Application design looks at the design of the interfaces, the user interfaces, and the application programs that are going to use the database. Of course, now someone is asking, now you're talking about application programs, now you're talking about the databases. There's two things you need to know. You have the actual database, okay, that you are going to design, the actual DB. But this DB does not work in isolation. This DB will have user interfaces, okay, and this DB also has transactions. So you need to identify what transactions are you going to have in your database. If you're looking at the bank, that means you'll have a transaction called withdraw, the one that withdraws and updates your financial statement, the one that deposits. If you're looking at a university database, transactions would be like the one that computes your GPA, computes your CGPA, etc. So you need to think about, you need to design your transactions. The same thing with the user interfaces. What particular interfaces do you intend to have? Okay, remember that interfaces have got to be understandable, easy to use, easy to learn, intuitive, etc. So all those things you have got to design them at this phase. Okay, so I said that a transaction is an action or series of actions that are carried out on this by a user or an application program which accesses or changes the content of a transaction changes the content of the database, and the content of the database can be changed either through deletion or updating the data that is in the database. This is an example of a transaction, a cash withdrawal, a cash deposit. And then transactions, there are usually three types. You have a retrieval that retrieves data from the database update. It inserts a new record or deletes all records in the database, or you can have a mixture of these transactions. So you need to ask yourself, are you looking at retrieval transactions, update transactions, or you're going to have a mix of those transactions? So the purpose of transaction design is to define and document the high-level characteristics of the transactions required. So the characteristics of the transactions, one, you need to know the data to be used in the transaction, the functional characteristics of the transaction, the output of the transaction. What particular output do you expect? Who are the users and how is it important to the users of the system? And then the expected rate of usage. How often are these transactions going to be how often are these transactions going to be used? Because then you are in position to know which DBMS can help you in terms of traffic. Then user interfaces I've explained. These are the go between the database and the users. So you need to have very nice interfaces that are easy to use, that are easy to navigate. Then we have phase 7, which is prototyping. Now the prototyping phase helps us to, one, it's optional. You may decide to prototype, you may decide not to prototype. But the purpose of prototyping is, some people use prototyping because they need to identify the features of the system. So you come up with a small working version of the system and then you take it to the users. And then through the process of using the system, they can identify features and then they communicate to you. Also, we use prototyping because we need to suggest improvements to the existing system. We need to clarify with the user requirements, and also sometimes we use it to evaluate the feasibility of the system's design. We have two types of prototypes. We have a requirements prototyping. This one helps us in gathering requirements from the users. After using it, we discard it. That's why we call it an evolutionary prototype. Sorry, we call it a requirements prototype. And then we have an evolutionary prototype which forms part of the system. So this one is we use it to determine the database application requirements. But once we have these requirements, we keep it. It is what we use to build on the system. In other words, we do not discard it. Then we have the implementation, okay, as another phase of the database. So this is now the physical realization of the database and the application designs. Here you're using the database definition language to actually do the actual programming. So here you program your forms, you program your menus, you program your reports, and many others. So after implementation, you go to data conversion. That is transferring the existing data into the new database. So if you were not working with the database previously, you have maybe file systems, then you need to convert and load the data into the database. Then testing, you have testing, we do testing to help us to identify any bugs in our system. We do it deliberately such that we can find errors in the system and we correct them before we deliver this product to the customer. So you use carefully planned test strategies and realistic data. Testing cannot show absence of faults. It can show only the software faults if they are present. So testing can be of different types. You can do a user acceptance testing. That is when you take the system to the users and they work with the system to make sure that it works and it meets their requirements. You can do a performance testing to ensure that the system is in position to handle any given types of requests. You can also do black box testing and many other kinds of testing. Then we go to our last phase, which is operational maintenance. Operational maintenance is a process of monitoring and maintaining the system following installations. So that means you have to constantly make sure that the system performs the way the system serves the purpose for which it was designed, but you have to constantly monitor it to make sure that the performance of the system is not compromised. So we also do maintenance if we want to. We can maintain and upgrade the database application. That is, if we deem fit. So we have different types of maintenance that we can do on our database. One, we have a corrective maintenance. Corrective maintenance is where, for example, the system has been attacked by a virus, or the system, there are some kinds of bugs in the system. So you correct by either installing an antivirus, by installing a spyware, by correcting the system bugs. So that is what we refer to as corrective maintenance. And then we have preventive maintenance. Preventive maintenance is you prevent the other things from happening. You prevent the viruses from attacking your system. So that is what we call preventive maintenance. You put up safeguards to make sure that the system is not attacked. And then you have perfective maintenance. Here you try to keep on adding features to your system such that it functions better than the original version of the system. So you keep on adding features, you keep on enhancing the system. That is what we call perfective maintenance. And then adaptive maintenance is that kind of maintenance that you do if you want the system to adapt either to the existing hardware of the organization or the existing software of the organization. That is what we refer to as adaptive maintenance. And so this marks the end of our lecture, the systems development life cycle. I believe that most of us will be able to understand that. Thank you very much. Have yourself a blessed day. Bye.